This is the question of extended linear equation. We can see here this can be written as dy by dx plus 2y upon x is equal to x to the power minus 3 multiplied by y to the power 3. Now we can see here this is the equation of the form dy by dx plus py is equal to qy to the power n, where p and q are functions of x only. Here we can see that p is here the coefficient of y, so this is 2 by x, and q is here the coefficient of y to the power n, that is x to the power minus 3. So on comparing this, we get p is equal to 2 by x and q is equal to x to the power minus 3, and n is here, this is the power of y, so this is 3. We can see that according to the definition of extended form of linear equation, p and q both are functions of x and n is constant other than 0 or unity. So first we divide this equation by y to the power 3 on both sides. So divide by y to the power 3 on both sides. Now this can be written as y to the power minus 3 dy by dx plus 2 upon x multiplied by, here this is minus 2 is equal to x to the power minus 3. Here we divide whole of the equation by y cube. So when we divide here y cube, so when we take in the numerator, so power will be negative, so this is y to the power minus 3 dy by dx. When we divide this term by y cube, so power of y is equal to 2. When we take in the numerator, so it becomes y to the power minus 2. Similarly, on the right side, when we divide this term by y cube, this y cube is cancelled out, so this becomes this. Now we put here y to the power minus 2 is equal to v, and differentiate this by with respect to x, differentiate with respect to x. So this can be written as d by dx of y to the power minus 2 is equal to dv upon dx. Now this can be also written as d by dy of y to the power minus 2 multiplied by dy by dx is equal to dv upon dx. When we differentiate this y to the power minus 2 with respect to y, it becomes minus 2 y to the power minus 2 minus 1 dy upon dx is equal to dv upon dx. Now this y to the power minus 2 minus 1, this is minus 3, so y to the power minus 3 dy by dx is equal to dv upon dx. Now this minus 2 divide on the right hand side, so this can be written as y to the power minus 3 dy by dx is equal to minus 1 upon 2 multiplied by dv upon dx. So suppose that this is equation 1. In equation 1, in place of y to the power minus 3 multiplied by dy by dx, we put here minus 1 by 2 dv upon dx. So this can be written as minus 1 by 2 dv upon dx plus 2 by x, and in place of y to the power minus 2 we put here v, so this is equal to x to the power minus 3. Now we multiply whole equation by this minus 2, so we get here dv upon dx minus 4v upon x is equal to minus 2x to the power minus 3. So this is the linear equation in V. So So compare this equation second by dv upon dx plus pv is equal to q. So in place here coefficient of v is p and here coefficient of v is minus 4 by x. So p is equal to minus 4 by x. Here q is equal to minus 2 x to the power minus 3. For solving this linear equation, we find out integrating factor. So this is e to the power integration of p dx, and p is here minus 4 1 upon x dx. So integration of 1 upon x is log x, so it becomes e to the power minus 4 log x. From the property of log, we can write here e to the power log x to the power minus 4. So it becomes x to the power minus 4. Now we write the solution of this second equation, linear equation. V multiplied by integrating factor is equal to constant plus integration of integrating factor multiplied by q multiplied by dx. So we put here value of v, that is y to the power minus 2, and integrating factor is x to the power minus 4 is equal to constant is here c plus integrating factor, that is x to the power minus 4, and here q is minus 2 x to the power minus 3. So we can see here this minus and plus minus, and 2 is outside the integral sign, and this minus 4 minus 3 add, so we get x to the power minus 7. Now we integrate this, so we write here minus 7 plus 1 divided by minus 7 plus 1. So this is c minus 2 x to the power minus 6 divided by minus 6. So this minus multiplied by minus we get plus, so this is 2 3 are 6, so this is 1 upon 3 x to the power 6, and here we can write this is 1 upon x to the power 4 y square. Now we taking here LCM on the right, so we get LCM here 3x to the power 6, so this is 3c x to the power 6 plus 1. Now we can see here this x to the power 4 cancel by 6 power, so we can write here this is x square 3x square is equal to y square multiplied by 3c x to the power 6 plus 1. So this is the solution of the given extended linear equation or Bernoulli's equation. This is the solution of the given linear equation or Bernoulli's equation. Now we solve the next question, that is here it is given that x dy by dx plus y is equal to y square log x. So for solving this, first we can see here this is dy by dx plus y divided by x plus y square log x upon x. We can see this is the equation of the form dy by dx plus py is equal to q y to the power n, where p is 1 upon x and q is log x divided by x and n is here 2. We can see this. So since this is the equation of the form dy by dx plus py is equal to q y to the power n, where p and q both are functions of x and here n is constant other than 0 or unity. So it is the extended form of linear equation or Bernoulli's equation. So for solving this Bernoulli's equation, we divide this whole equation by y square. So divide by y square. So we get here y to the power minus 2 dy by dx plus y to the power minus 1 divided by x is equal to log x divided by x. First we identify uh, which is the form of this first degree differential equation. So we can see here this equation can be written in the form dy by dx plus py is equal to qy to the power n, where p and q both are function of x and n is the constant other than 0 or unity. So we can see here this is the extended linear equation or Bernoulli's equation. So for solving this, first we divide this equation by y square and we get this. Now we put here y to the power minus 1 is equal to v. Now we differentiate with respect to x. So we get here d by dx of y to the power minus 1 is equal to d by dx of v. This can be also written as d by dy of y to the power minus 1 multiplied by dy by dx is equal to dv upon dx. When we differentiate this y to the power minus 1 with respect to y, so we get minus 1 y to the power minus 2 dy by dx is equal to dv upon dx. Now we divide this taking this minus 1 on the right hand side. So we write here y to the power minus 2 dy by dx is equal to minus times dv upon dx. Suppose that this is one equation. So in one equation we put value of y to the power minus 2 multiplied by dy by dx is equal to minus dv upon dx. So minus dv upon dx plus, in place of y to the power minus 1 we put here v. So this is v upon x is equal to log x by x. Now we multiply this equation by minus. So we get here dv upon dx minus v upon x minus times log x upon x. We can see here this is dy by dx plus pv is equal to q. This is the linear equation in V. So this is the second, suppose this is second equation. So this is linear equation in V. Now we can compare these two equations. Here coefficient of V is P, here coefficient of V is minus 1 upon x. So P is equal to minus 1 upon x. Here q and here minus log x upon x, so this q is equal to minus log x upon x. Now we find the solution of equation 2, which is linear equation. So for finding the solution of linear equation, first we find out integrating factor. So integrating factor is e to the power integration p dx, and p is here minus 1 upon x dx. So integration of 1 upon x, this is log x. So here we can find integrating factor. So integrating factor is equal to e to the power log x to the power minus 1. So it becomes x to the power minus 1, it can be written as 1 upon x. Now we write here solution of equation 2, which is v multiplied by integrating factor is equal to constant plus integration of integrating factor multiplied by q dx. So we put here value of v, which is y to the power minus 1, and integrating factor is 1 upon x is equal to constant plus integrating factor 1 upon x, and q is here minus times log x upon x dx. Now this y to the power minus 1 goes to the denominator, it becomes y to the power 1, this is c, and plus and minus, this is minus, this is log x upon x multiplied by 1 upon x. Now for integration of this, we put here t is equal to log x. Now differentiate this with respect to x, so dt upon dx is equal to 1 upon x. So from here we write dt is equal to dx upon x. We can see here c minus this dx upon x is equal to dt, and this log x is equal to t, and from here we can see that x can be written as e to the power t. So in place of x we put here e to the power t, and when it goes to the numerator it will be e to the power minus t. Now we integrate this by part, integration by part, taking t as a first function and e to the power minus t as a second function. So first we write here first function, that is t, integration of second function, that is integration of e to the power minus t, is minus e to the power minus t, minus first we differentiate first function, that is differentiation of t with respect to t, that is 1, and then integrate e to the power minus t, that is minus times e to the power minus t. Again we integrate e minus times e to the power minus t, we get e to the power minus t. So here we write e to the power minus t. So we can see here this can be written as 1 upon xy is equal to c minus, here we taking common minus e to the power minus t, so this becomes plus, and here t plus 1 e to the power minus t. Now we put here value of t. So we can see here value of e to the power minus t, here we can see here e to the power minus t, this is equal to 1 upon x. So c plus, here value of t, that is log x, so 1 plus log x, and e to the power minus t, this is 1 upon x. So 1 upon xy is equal to c plus 1 plus log x upon x is the solution of given extended linear equation or Bernoulli's equation. Thank you.